Okay, so the first thing they want me to find is arc AB. What would the measurement of that arc be? (49°), thank you. Arc AB would be 49 degrees. Then we have angle DOE. Start at D, travel to O, and then over here to E. So this is the angle that we're looking for. What would the measurement of that angle be? 41 degrees. Yes, it's a vertical angle over here with BOC. So that would be a 41-degree angle. And then we have arc DCB, starting at D, come past point C, and end over here at point B. What do we know about segment DB? It's a diameter. BD is a diameter. So BD is cutting my circle exactly in half. It's going through the center and edge to edge. So that means arc DCB would be how many degrees? 180. Angle COD. C over here to O and then down to D. This angle right here is the one that we're looking for. Well, what did we just say about arc DCB? It's 180. And arc DCB is including the angle that we're looking for right here, and then it also includes this. So if I can get rid of this part, I am left with just this piece. So how could I find that? Yes, 180 minus 41. And what is 180 minus 41? You said 139 degrees, yes. Last thing we need is arc AD. So starting here, around to here. So we're going to have to figure out how big this arc is, and then I can add 41 to it. Or, yes, it is 90, absolutely. Or there's something else that I could do. What do we know about BD again? It's a diameter, right? So from here around to here would be how many degrees? 180. And I want to get rid of this part so that I have just arc AD. So what could I do to find this arc right here? 180 minus 49 would be how much? 131 degrees. Very nice work. All right, we are going to be in your notes today on page 8, which is the back side of the fourth piece of paper. You are going to turn in your warm-up today, so if you want to turn in both your homework and your warm-up now, you may absolutely do so, or you can wait until the end of class to turn those both in. It is up to you. So again, page 8 in your notes, back side of the fourth piece of paper. We're going to talk about something called an inscribed angle today. So we talked about a central angle before. A central angle is an angle that is formed by two radii. So it has its common vertex at the center. So this is a central angle. And the measurement of the central angle, let's pretend this is 15 degrees. The arc that it captures has the exact same measurement. An inscribed angle is an angle formed by two chords. Two chords that have a common vertex, a common endpoint. The vertex is on the circle. It is on the circumference of my circle. So this is an inscribed angle. We're going to go ahead and name this angle. We're going to call this one A, this B, and this C. So we would have angle ABC. The measure of my angle, ABC, is going to be half of the arc that it captures. So half of arc AC. And therefore the measure of the arc, I forgot to put the arc symbol there, the measure of the arc is 2 times the measure of the angle. So the angle is half of the arc is double the angle. If an angle is inscribed in a circle, like the one up above, then the measure of the angle equals half of the measure of its intercepted arc. And if we have two inscribed angles on a circle that intercept the same arc, then the angles are congruent to each other. So let's practice a little bit with this. Example number 2 here. Part A, we're supposed to find the measurement of arc CF. So we want to find the measurement of this arc right here. Well, I see that C has 2 line segments coming out of it. It's got this one, but that doesn't lead back to an angle. This one, however, does lead back to an angle, because I noticed that this line segment from F also comes back here. So this is my inscribed angle. And what's the relationship again between the inscribed angle and the arc that it intercepts? The angle is half of the arc, but the arc would be what? 2 times the angle. So the measurement of arc CF is equal to 2 times the measurement of angle CDF. And angle CDF is how big? 40 degrees. What is 2 times 40? 80. So arc CF is 80 degrees. So right here. The other thing they want me to find is the measurement of angle C. Well, here's the vertex for C. Angle C has to have one segment going this way, and then here's my other segment. And so here is the arc that it's intercepting. This is my intercepted arc. And so this would be my inscribed angle that was intercepting that arc. The measurement of the inscribed angle, looking up here, my angle is equal to half of my intercepted arc. Well, the arc that this is intercepting is DE. How big is arc DE? 98 degrees. What is half of 98 degrees? 49 degrees. So angle C is 49 degrees. The arc is twice as big as the angle. The angle is half as big as the arc. When we are working in this section, so today and Monday, and then when you're working on the homework as well, different colors, highlighters, pens, colored pencils are really helpful so that you can make the connection between the arc and the inscribed angle, or between the inscribed angle and its intercepted arc. Especially when we're looking at pictures where they have several inscribed angles and several intercepted arcs. All right. So that used our first property right here. If an angle is inscribed in a circle, then the measure of the angle is 1/2 of its intercepted arc. I want to come down and look at problems that are using this second property here. If an inscribed angle on a circle, if inscribed angles on a circle intercept the same arc, then the angles are congruent. So let's look down at example number 3 here. Number 3, part A. We've got this weird thing going on here, but I want to show you how you can look at this to help you solve this problem. We are supposed to find the measurement of angle A. Here's A, and I have 2 line segments coming out of that point. So this right here is what they're referring to as angle A. And they say it is 5x minus 12 degrees. Here is the arc that it is intercepting. But when I look at that arc, I notice that there are 2 more sets of lines coming into it. B also has this line coming into it, and C has this line coming into it. So angle A and angle D are intercepting the same arc. When Darwin gets back. Angles A and D are both intercepting arc BC. So that means that angle A and angle D are congruent. If those 2 angles are congruent, what can we do with their measurements? Set them equal to each other. So the measurement of angle A is equal to the measurement of angle D. How big is angle A? 5x minus 12. And I'm going to set that equal to the measurement of angle D, which is how big? 3x plus 2. And now we're going to solve this for x. So I'm going to subtract 3x from both sides. That would give me 2x minus 12 equals 2. Then we're going to add 12 to both sides so that I get 2x equals 14. And then we'll divide both sides by 2. I get that x is 7. Am I done with this problem? What did they want me to do? Find the measurement of angle A. Well, the measurement of angle A is how big? 5x minus 12. And we just figured out that x is 7, so we're going to put 7 in the place of x. So 5 times 7 minus 12. What is 5 times 7? 35. So I have 35 minus 12. And 35 minus 12 would give me what? 23. So the measurement of angle A is 23 degrees. Let's try part B. We want to find the measurement of angle T right here. Well, angle T is this angle right here. And it is intercepting arc SV. Are there any other angles that are also intercepting arc SV? U. Angle U is also intercepting that same arc. So angle T and angle U both intercept arc SV. So angle T is congruent to angle U. Which means we can do what with their two measurements? Set them equal. The measurement of angle T equals the measurement of angle U. Angle T is 3x minus 5. Angle U is 2x plus 15. We're going to solve this for x now, so I need to minus x from both, minus 2x from both sides to get my x's to the same side first. What is 3x minus 2x? 1x. So I have x minus 5 equals 15. Then I'm going to add 5 to both sides, meaning x is 20. They wanted me to find the measurement of angle T. Measurement of angle T is 3x minus 5. We just found out that x is 20, so 3 times 20 minus 5. What is 3 times 20? And 60 minus 5? 55. So the measurement of angle T is 55 degrees. So far, so good? Awesome. Let's look at number 4. Number 4, they want me to find the measurement of angle ABC. Well, here's A, here's B, and here's C. So angle ABC is this angle right here. What do I know about the relationship between the arc and the angle? This was our first bullet point up there. What do we know about the relationship between the arc and the angle? The angle is inscribed. Here's my inscribed angle. So that means this is my intercepted arc. What kind of numerical relationship do we have between an inscribed angle and an intercepted arc? What'd you say? They are not congruent. That is when it's a central angle. So when the vertex is on the center, then they are the same size. What was the relationship that we wrote down up at the top of the page between the inscribed angle and the intercepted arc? It's half. The measure of angle ABC is half of the intercepted arc, so arc AC. So the measurement of angle ABC would be half of 84 degrees. And what is half of 84 degrees? 42. So angle ABC is 42 degrees. All right. Part B of this question, they want us to find angle T. Here's angle T. So this is the angle that we want to find. What is the arc that angle T intercepts? What is the arc that angle T intercepts? RS, right here, this end point of the angle, and then around over here to this end point of the angle. So angle T intercepts arc RS. What's the relationship between the angle and the arc? Thank you, sir. Half. So the measurement of angle T is half of arc RS. Do I know how big arc RS is? No. However, do I know how big the other arcs in the circle are? Yes. And how far is it? How many degrees is it if I go all the way around the circle? 360 degrees. So the measurement of arc RS plus the measurement of arc ST plus the measurement of arc TR is equal to 360 degrees. We don't know how big RS is, so I'm just going to leave that measurement of RS. Do we know how big ST is? 200 degrees. What about TR? 60 degrees. So I have the measurement of arc RS plus 260 degrees equals 360 degrees. So how big is arc RS? 100 degrees. So I'm going to go up and add that to my picture. This is 100 degrees. And this angle back here, you told me, is half of that. So I have the measurement of angle T equals half of 100 degrees. And what is half of 100 degrees? 50 degrees. So angle T is 50 degrees. The angle is half of the arc. Do we have any questions before we go and look at the problem at the bottom of the page? This is where we're going to stop for today, down here on number 5. All right, so one more problem. Number 5. You need to get your notes back out, please. We're still working. Guys, we're still doing number 5. I asked if we had any questions before we went to do the last question. Number 5, they want me to find the measurement of arc QR. Well, what do you notice about SQ? What would we call SQ? What part of a circle? What'd you say? Arc SQ would be a semicircle, yes. Segment SQ would be a diameter. So because arc SQ is a semicircle, that means it measures how many degrees? For a semicircle? 180 for a semicircle, half the circle. If I could figure out how big arc SR is, I could minus that from 180, and that's how I could find QR. Do I have enough information to figure out the size of arc SR? Yes. What angle is capturing arc SR? Angle P. How big is angle P? 47 degrees. What's the relationship between the angle and the arc? The angle is half of the arc, so the arc would be 2 times. So the measurement of arc SR is 2 times the measurement of angle P. And angle P is how big? 47 degrees. So I have 2 times 47 degrees. What is 2 times 47 degrees? You said 94 degrees. All right, so I'm going to add that to my picture over here. This is 94 degrees. The measurement of arc SQ is equal to the measurement of arc SR plus the measurement of arc QR. We know that SQ is how big? 180. How big is SR? 94. Plus the measurement of arc QR. So we're going to minus 94 from both sides. And that means that QR is how big? What is 180 minus 94? (180 minus 94). 86 degrees. Thank you. All right. Part B, last one we're going to do today. First thing they want me to do is find the measurement of angle B. So this angle right here. What's the relationship between the arc and the angle? What is the relationship between the arc and the angle? I want to find the angle. So what do I need to do to that arc measurement? Divide it by 2, yes. The angle is half of the measurement of arc CD. So I'm going to do half of 136 degrees. What is half of 136 degrees? (68 degrees). So angle B is 68 degrees. They still want me to come in and find arc BD, this arc right here. Well, what do we know about chord BD and chord CB? They are congruent. And if I have two congruent chords, what does that mean about their arcs? They are congruent too, so I'm going to call them both X. And how many degrees is it all the way around a circle? 360 degrees. So I have X degrees plus X degrees plus 136 degrees equals 360. So I'm going to combine my X's first. 2X plus 136 equals 360. Then I'm going to minus 136 from both sides. What is 360 minus 136? 224. Then we're going to divide both sides by 2. And that means X is how big? 112. So how big is arc BD? 112 degrees. Perfect timing. The homework that you guys picked up on your way in the door is due on Tuesday. Due on Tuesday. You guys can go ahead and get started on that homework. We are going to continue working with inscribed angles on Monday.